And using the specific heat capacity of water is an extremely important tool when measuring energy changes during chemical reactions. So let's see if we can work out what it is and how we use it. So let's start off with 1 gram of water. And we're going to transfer thermal energy to that water by heating it. And in this example, we're going to use exactly 4.18 joules of energy. So that might come from my chemical reaction. We're transferring that amount of energy to my water. And what we'll notice if we measure the temperature of the water is that the temperature increases by 1 degree. So, because it takes 4.18 joules to heat 1 gram of water by 1 degree, we can write the specific heat capacity, which has the symbol of C, something like this. And you'll notice in the units there that we are talking, there's the 4.18 we mentioned, that is joules per gram per degree centigrade of temperature increase. So if we look in the actual data booklet, we'll see something similar written for the specific heat capacity of water with a slight difference. And you'll notice the difference here is that actually instead of having per degree at the end, we've got per Kelvin. However, fortunately for us, the change in temperature in degrees centigrade is exactly the same as the change in temperature of degrees Kelvin. So I can simply use exactly the same number, in this case 1 degree, because that change is the same in both of those units of temperature. The other way I might see this written in the data booklet is like this. We've got the same number, 4.18, but this time we've got kilojoules per kilogram per Kelvin. And that is effectively exactly the same as the units we saw before. It's just because if I increase the mass by a factor of 1,000 to get from joules to kilojoules, then the heat required is also going to increase by a factor of 1,000. So we can simply write kilojoules per kilogram per Kelvin instead. So let's take a quick look at those units in a bit more depth and see if we can work out the formula to use when we are given information about specific heat capacity. So first of all, let's have a look at our units of specific heat capacity. We just saw we've got joules per gram per Kelvin. Now I could write this a slightly different way. If I've got any units to the power of -1, we can simply write that as joules over grams and Kelvin. Now that's helpful for us because if we know what those units are representing, we can start to write a formula for specific heat capacity. So I know that my joules were representing the heat or the energy transferred to my substance. The mass in grams is referring to the substance itself. And then of course we've got change in temperature in Kelvin as well. Now if I know the symbols for those 3 variables, I can rewrite that in a nice simple formula. Not that one there. Heat we represent with a Q, mass we represent with an M, and change in temperature has that funny triangle symbol, which is technically called delta. So delta T means change in temperature. And then from there, I can simply rearrange that to give Q equals. In that case, I would need to multiply both sides by M and delta T. And I end up with this formula at the bottom here, which is actually the one I find in the data booklet. So you can either go straight to the data booklet, or actually if we remember that the units of specific heat capacity are joules per gram per Kelvin, we can kind of work it out and it's helpful for our understanding. So let's have a quick look at an example then of how we might use this in an IB question. Let's take the following example. Here we go. I've got 50 centimeters cubed of water, and you'll notice I haven't written grams yet because we're normally measuring the volume of water, not the mass of it. And we're going to place a chemical reaction underneath, which is going to heat my water. And let's say in this example, my temperature increased by 13.3 degrees. And our job is to work out Q, or the heat, the energy that was transferred to that water. So we can go to the data booklet, or we can remember the formula ourselves, which was Q equals mc delta T. And now all we need to do is work out what each of those values is and multiply them together. So first of all, the mass of the water, and remember we should be talking about mass, not volume, is actually going to be 50 grams. And useful for us to know that the kind of assumption we're making, or as long as we're dealing with pure water, 1 centimetre cubed of water is going to have a mass of exactly 1 gram. So I can simply transfer the number of centimetres cubed to the number of grams. The second thing we know from the data booklet is the specific heat capacity of water. And that word specific in there just means it's specific to a particular substance. So this value is for water. Other values we'll find for metals or gases or whatever will be different. And the change in temperature here, well, we have an increase of 13.3 degrees centigrade. And you'll remember from the previous bit that that is exactly the same change in temperature on the Kelvin scale as well. So the final part, once we've got those three values, is stick them back into our formula. And that gives me an answer something like 2,279.7. However, in IB questions, we need to look at the data we're provided with, specifically the measurements. So that would be a measurement, and that would be a measurement. And you'll notice they've both got 3 significant figures. So in my answer, I want to make sure I've got 3 significant figures as well. And that's pretty much it for specific heat capacity of water. Hopefully this video is of some help.